Angle pair relationship notes, page 17. So first, how we name the point. This is capital letter A, B, C, whatever you guys have it. And naming a line, it depends. It has to have a start and finish. So D, E, J, E, DJ, ED, whatever way you want to, but the line has to have a line on the top with the arrows because that means it's a line. It goes forever. The line segment, on the other hand, has to have endpoints. So if I would call the line segment, I would call it the same as a line, except on the top it would have just a line, no arrows. The we call the figure by the corner, by the vertices. So this is triangle ABC or triangle CBA or BCA or whatever way. Usually we try to go alphabetical order. So the angle at B is written as angle B, and the measure of angle is 80 degrees. And we also write measure of angle is 80. So to say it is angle B, but if we say measure of angle, we put M in the front. The length side BC is written at BC, has to have a line on the top. Sometimes you're going to see in the book BC with this. That means a length also. Okay, the ray has to have a start and it goes forever. So let's say this is a ray GH. So you have to call it by the start, by the vertex. Where does it start? So GH, GI, GF, and it's a ray. So it goes forever only one direction. So we put one arrow on the top. Okay, angles. If I don't have one single angle, for example, this one we can call angle F because it's only one of them. This one, B, is shared by three angles. It's shared by angle A, B, C. It's shared by angle A, B, D, or uh, C, B, D. So if I look at this one, naming the angles, this one angle I can call FGI. That's the biggest one. Then I have angle FGH. And then I have angle H. I'm sorry, I called it IGH. The point of this, your vertex is the point of it, guys. The vertex is always in the middle of the name of the angle. So the one there they go to. Okay. Two angles have the same. They add up to 90 degrees, so their sum is 90 degrees. We call it complementary, and you can think about it. It started with a C, so it's easy to turn C into 9, and that's how you get 90. So also 90 degrees, it's going to be a square showed on the picture. If the sum of them, the measure of two angles is 180, we call it supplementary, and again, supplementary started with S, so you can change it easily to 8, and that's how you get a 180. And then this picture is unnecessary here. I don't know why is it here. The two lines, when they intersect, they form angles. They actually form four angles. So the opposite angles are called vertical angles. So I get those two are vertical, and also those two are vertical. Okay, now proving examples on vertical angles and angles 180 degrees. So they call those AEC, DEB, and CEB. So we gotta stick with this. So AEC, AEC, this is this angle, okay? With angle X, it's forming a straight line. This is called linear pair, and linear pair is supplementary, so always straight line is 180 degrees. So to find this angle, I would take 180 minus 23, and it turned out to be 57. If I have this angle 57, I can find the angle opposite of this because that's a vertical, and this one's called DEB. So DEB is also 157 because it's vertical to the one we just found. And then we have angle CEB. This angle is vertical to angle X, and angle X was given to us as 23. So that one is also 23. So the angle, if they're exactly the same, we call them congruent. This should be uh, the last one, but don't worry about it. So we got vertical angles and we got linear pairs here. But okay, now this one goes a little bit with geometry, writing stuff. Conjecture. Conjecture is a statement based on incomplete evidence. So it's not proven yet. So this is something what you think is going to happen. So the way we write a conjunction, you can just write if angles are vertical, then they're congruent. This sounds like a statement, but that's your conjecture. So usually you want to write your conjecture if then, or angles are vertical, they are congruent. That would be your conjecture. So to prove this, we can use this uh, thinking that is in this problem. So all the angles are always congruent if they're vertical. Yes, that is always true. And if you look at this picture, this angle A, B, and C, and they gave us two statements. One of the statement is AB equals 180, which is true because they form a straight line. And the second statement is AC is 180, which is also true because this is another straight line. So from those two pieces of information, we can actually prove that vertical angles are congruent. So I'm going to solve both of them for A because they have those in common. So A will be 180 minus B from this equation, and A will be 180 minus C from this equation. So if one thing equals A and the other thing equals A, that means they're equal to each other, right? Because if measure of something is 5 and a measure of something else is 5, that means those two are really the same. So I am solving this. If I take away 180 from both sides, I will cancel. I will get negative b equals negative c. And if I divide both sides by -1, I get b equals c. So my two angles b is congruent to c. I can do the same thing by using c and then find that a and this angles are congruent. So every angles are congruent. This one, guys, is just for you to read, so please read that. And those are the notes for angle relationship.